So both of these methods, zero carbon and passive house that we've discussed, all have fabric first at their key. It's a back to basics approach that you all should be doing as part of what you're doing. And it's getting the forever bit of the house right, not the eco-bling, as I like to call it. You can see I have an issue with people having to put in very expensive heating systems when they actually don't need it. So fabric first will get you around that if you stick with it. And again, it works for extensions, it works for new builds, and it can also be replicated in renovations. So some of the design principles: highly insulated building envelope, and you're limiting the cold bridges, so we'll discuss that a little bit later on. High specification windows and doors. Again, airtight membrane, so every gap in construction you're using airtight tapes to try and limit the air that is leaking out of your building to get back to your 50 pence piece. Heat recovery system for fresh air. Maximising the natural solar gain, so you're designing the house to make the best use of the site and the solar gain that you're getting for free. I know we don't get a lot of it here, but we do get a bit, and it is still, you still can use it and design it into your house. And then again, at the very end, you're looking at how you power and how you heat the house. It's getting the fabric bit right and then worrying about the renewables or the heating source. So the key elements, you have to think about the construction type. How are we actually going to build this? Get the air tightness right, limiting cold bridging. I'll try not to be too techie on that. Ventilation strategy, the solar gain of the site and of the house, and then again at the end we're looking at the heating systems that you can use. So construction types. What I would suggest is that there are lots of different construction types that will get you to an airtight, low energy house, but there are some construction styles and types that will do it easier and better. We always try as architects to design out processes and stages. So if you can do it in one product without having to add lots of different things, to me that's a simpler process, a better process where you're actually eliminating chances for things to go wrong. So choose a construction type that's naturally airtight, it's highly insulated, and ideally, I'm a firm believer, we do modular housing and we do lots of different stuff. If you can do it in a factory rather than a cold, wet site, it will be better. So, timber frame, traditionally it's become, I now class it as a traditional construction method, but it can get very easily, you have to add a little bit of air tightness and some more insulation these days, but you can use it very easily, very cost effectively to get a low energy house. The other thought is SIPS, which is taking timber frame that bit further. It's a rigid system, so the insulation is bonded to OSB, which is a very airtight product inherently. That comes as one process. That's one panel that slots onto another panel that you can then make airtight very easily. ICF is another really good product for getting an airtight, low energy house. One of the benefits of ICF is you're actually creating thermal mass. So timber frame construction has very little thermal mass. Thermal mass effectively will store the heat during the day and then it will release it during the night. That's all it will do. Something with low thermal mass, the heat will just transfer through it. Something with high thermal mass, it'll store it. So that's really good. ICF is really good for that because concrete is a very good, it's a lot of mass, lots of density, and it will store the heat. So that's one of the plus points of ICF. The other way that we get thermal mass in buildings, if we are using, say, timber frame or SIPS, is in the floor slab. So you have an insulated, thick concrete floor slab that effectively your whole ground floor becomes a radiator, and it just stores the heat during the day. If you are looking at a fabric first type of house, you will be looking at limited heating on the ground floor only, nothing on the first floor. So even if you are having to put some heating in, you just don't need it in the first floor. Some of our clients still don't even believe us, we can prove it, and will then put heating on the first floor for comfort only. And they'll waste six or £8,000 on it, but some people still want comfort. It's still nice to be able to get out of bed and have warm feet. So you can do things like that, but you will not need it to heat the house. There is a bit of a mindset, and you need to have the right professionals guiding you on giving you the right information that you can trust that actually you don't need to do that. So that's a bit about the construction types for fabric first. Air tightness again, I'll bang on a little bit more about it, but it has become so key in getting your building right. And don't worry about if you're building an airtight house, you are still allowed to open the windows and doors. There isn't an airtight police that come along and put you in jail for opening the windows and doors, but there seems to be this perception that I've got an airtight house, I must close everything all the time. Actually, in passive house, that is one of the summer methods for ventilating. It's purge ventilation, i.e. opening a window and door. So you are still allowed to do that. So use tape around all the external windows and doors. I'll jump onto this next image. So this is an image of a SIPS house, and the black lines that you can see is just an airtight tape. And all you do, and I always suggest that the clients do it rather than a labourer or somebody on site, because you see it as it's a workmanship check as well. You're going around every inch of your building. Our clients usually come home at night and do it, and they'll end up taping themselves to something in their building, but it's good fun, and you know that every piece of construction jointing is right. And again, that goes back to trying getting all the holes of the house back to that. It doesn't just magically happen. So there are other ways of doing it. The image on the left-hand side there has got a red sticky membrane on it. It's a Proctor product. It's wrap tight. Effectively, you're wrapping the whole building in a breather membrane, so it actually will cut out a lot of the problems that you have with, say, timber frame, where it's not quite as airtight a construction. So there are, as I said, it's better to pick something that does it right to start with, but there are other products out there that will help the different construction methods. And please tell everybody that comes on site that this is what I'm trying to do. I'm trying to create a low energy house. If you cut a hole in my building, please tell me, because there is a foam, there's a material that will cover all of the holes that you need to do. And if you see your window fitter putting squeegee foam round the windows, that has no airtightness property whatsoever. So they have to be taped in. The windows are taped rather than you actually design it with a bigger hole, bigger structural hole that you can fit them in, and then you tape on the inside and have a proper seal on the outside. We don't use squidgy foam that expands and makes a mess, because it doesn't do anything, and it's just a pain. So cold bridging is a very technical subject, but effectively everything that has a different construction method that can touch from inside to outside, that can transfer heat through the building, you want to eliminate as quick as possible. So your architect, if you are going to somebody to get an airtight, energy efficient, low energy house, they will be detailing all of the major construction details to eliminate cold bridging. It's something that happens in all houses, but you try and eliminate it as much as possible. So this is a quick detail that traditionally we used to, on a timber frame, we would have the external wall, and then we'd put the floor that ran right the way to the outside. You were then supposed to insulate all the way around it. Never happened. So you had a 300mm zone all the way around your house that wasn't insulated. Now what we do is we hang the floor off of the top of the joist so it's inside. So your insulated envelope runs all the way up and round. So it's clever details like that will get you the right design. And if you do all of these different things, you have to do a SAP calculation to get through building control. If you put all of these different details together and you have detailed it right and you build it right, it makes a 28% difference. So when you start going through the process with your architect, you'll find out that going from a double glazed window to a triple glazed window will make a 2 or 3% difference and cost you £30,000 or £40,000 difference. Detailing this right and building it right makes a 28% difference. So that's a massive number on the whole thing. So just keep in mind that whoever is designing this and then building it, that you have to have buy-in from everybody. Another way that we've actually started doing only just in the UK now is a Swedish detail that we now insulate round the foundation. So traditionally in the UK we do a strip foundation, we build blockwork up, and then we insulate on the inside of that. But there's a whole bit of blockwork that runs from the outside to the inside, ground up, that's uninsulated. So we use a passive slab detail now where we insulate around the slab. It's actually a lot easier to do on site. So it reduces time on site and it will have a huge benefit on the costs and the running costs of the build. It does only have certain ground conditions, so you can't use it everywhere. It has to be a relatively level site with the right bearing in the ground. So ventilation, you have to consider ventilation. If you are creating an airtight house, you have to manage the ventilation. You cannot just rely on the old-fashioned trickle vents that you had on your house. So traditionally we have put little holes in the top of our windows with little plastic covers that we close and open, and that brings in cold air into our house. It's unmanaged. With a heat recovery system, it's managed heated air. So you can manage exactly what you're doing and control it throughout the house. And it will recirculate the air up to 10 times more than the trickle ventilators will. So it's a lot cleaner air that you're going to have in your house. And in Scotland, if we sometimes need to have post and preheating elements. So if you've got very, very cold air coming in, you don't want to freeze the heat exchanger. And passive house, as I said, you do put an element of post-heating, which is your only heating in the house. A lot of the companies that are here today will design and commission the MVHR system. That's fine, but just make sure you do get somebody, a professional, to come in and commission it, because it can be installed by anybody, but just make sure it is completely conditioned, or the whole point of it will be missed. So solar gain is a hugely important part of all the design. Maximising the orientation of the building, having lots of big openings on the south windows, and smaller openings on the north. Now that may not be practical if all of your views are to the north, but you have to have a trade-off on how energy efficient you want to be and how much of the view you want to get. So there is a design trade-off there. We still have a problem, even in Scotland, with summer overheating. So if you have overhangs or brise soleil, they can stop the highest summer heat but let through the lower winter heat. So there's things like that that need to be accounted for in the design of the build. And lastly, in the Fabric First approach, you're finally only looking at what the heating strategy is. So if you're doing a low energy house, even in Scotland, you can get your heating demand down to 3 or 5 kilowatts. So it's a very small boiler if you are going for the Fabric First approach. My approach with our clients is, if you've got mains gas, still use it. Small boiler, underfloor heating, that's still the most cost-effective way. There are a lot of new incentives and new grants that are coming out for air source and ground source, but there's still a huge amount of money that you have to put in to start with for such a low heating demand. So if you can bring the heating demand very low down, you can actually cut out having ground source or air source. But it needs to be done by a professional and done by heating engineers that can give you the calculations and prove exactly what you're going to do. If you are having ground source, air source, water cylinders, heat recovery system, make sure you design in a plant room, because all this stuff does mount up. You do want to have it in a room, and it's also a great idea, that room will become really hot, so actually extract your heat recovery from that and use that heat that you're generating as well. Little design ideas like that really can help.